Right, so the addition rule. A and B are if A and B are mutually exclusive events, then the probability that A or B occurs, the union of our events, is going to be the probability of A plus the probability of B. We'll add those. Okay. In your notes, I want you to add the stuff I have written down there. So probability of A or B is the probability of A plus the probability of B only if the events have no outcomes in common. There's no outcomes in both groups. They are mutually exclusive events. And you can just put that right underneath where this is in your notes, this room. The next question there, the survey of college students, that does not belong in this section. We're going to cover it in the next section, so you might want to draw an arrow showing that it should be at the bottom. So we'll do that when we get to the bottom of the page. Okay, turn the page. All right, so probability, we're finding the probabilities of mutually exclusive events. A group of students is donating blood during a blood drive. A student has a probability of having type O blood and a probability of having type A blood. Explain why the events type O and type A blood are mutually exclusive. Orange 4. No orange 4? Green 4. So why are type O and type A blood mutually exclusive? Why would those be mutually exclusive?
Because they cannot occur in the same trial.
Right. Then you can't have two different types of blood. You can only have one type of blood, right? So those are mutually exclusive. All right, so for mutually exclusive events, and this is in your notes, the probability of two mutually exclusive events, A or B, occurring is the sum of their individual probabilities. All right, so for two mutually exclusive events, we just add those together, the probability of A plus the probability of B. So for instance, when a number cube is rolled, we want the probability of less than 3, we would add the probability of 1 and the probability of 2. So the probability of 1 or 2 is, since they're mutually exclusive, we would add the probability of rolling a 1 plus the probability of rolling a 2. So the probability of rolling a 1 is a 1/6, because there's 1, 1, and there's 6 outcomes. Probability of rolling a 2 is 1/6, because there's 1, 2, and 6 outcomes. And then together that's 2, 6, or that reduces to 1/3. So the union symbols for OR. When we see OR, it's the union symbol, and we're going to add them together. All right, so back to our blood. A group of students is donating blood during a blood drive. A student has a 9/20 probability of having type O blood and a 2/5 probability of having type A blood. What's the probability that a student has type O or type A? So what do we do to find that answer? Orange 1. How would we find the probability of type O or type A? What would we do? We'd add them together. So we're going to add the probability of type O and the probability of type A. Right, so probability of type O was 9/20. And the probability of type A is 2/5. We need a common denominator there. So we got to change the 2/5. 2/5 is how many 20ths? So 4 times 2 would be 8 20ths. All right, so our probability of type O or type A is going to be 17 20ths. And the other 3 20ths would must have the other types of blood, right? Type B or type AB, which is not A and B at the same time. It's its own blood type. Okay, so if they're mutually exclusive, we just add those together. A student each student casts one vote for senior class president. Of the students, 25% voted for Hunt, 20% voted for Klein, and 55% voted for Vila. A student from the senior class is selected at random. Explain why the events voted for Hunt, voted for Klein, and voted for Vila are mutually exclusive. Red 2. Why would those be mutually exclusive? So why would those events be mutually excluded? Voted for Hunt, voted for Klein, voted for Vila. Yeah. Each student can only vote once, right? You get to vote one time. All right, so we want to find what's the probability that a student voted for Klein or Vila? How would we find that answer? Red 1. Yeah. All right, so we'll add the percent that voted for Klein and the percent that voted for Vila. So it was 20% voted for Klein and 55% voted for Vila. That means the percent of students that voted for Klein or Vila would be the sum of those two, and that would be 75%. Any questions so far on mutually exclusive events? Because we're going to be moving off of mutually exclusive. So we're not going to be looking at the survey of college students with the jazz until a little later, but let's continue on and look at inclusive events, non-mutually exclusive. So over this word, you could put for inclusive events, you could also put non-mutually exclusive. Sometimes it's referred to as that. Non-mutually exclusive. So those are, whoops, there goes more sticks on the floor. I'll put it above. Non-mutually exclusive or inclusive events are events that have one or more outcomes in common. When you roll a number cube, the outcomes rolling an even number and rolling a prime number are not mutually exclusive. The number 2 is in both prime and even, so the events are inclusive. Right, so I want you to add to your notes, there are some outcomes that appear in both groups. We need to make sure we don't count any outcome twice. Right, so that's why we're going to have to calculate out the probability for non-mutually exclusive events different than mutually exclusive events. We want to make sure we don't count anyone twice. Right, and right now, 2 is sitting in both groups. It's an even number and it's a prime number. Right? We'll calculate out that probability in a little bit. But let's look a little bit more at non-mutually exclusive. All right, so this is in your notes, and then I want you to add a little bit to the part that's in red. So if A and B are not mutually exclusive, then the probability of A or B, the union of A and B, will occur is, so this is an inclusive event, not mutually exclusive. We're going to still add the probabilities of each event. So we're going to add the probability of A plus the probability of B, but we have to subtract any probability, any outcome in the intersection. If we don't, we're going to count it twice. We're going to count it once for A and once for B, and it doesn't get to be counted twice. Okay? So for a joint probability of two things occurring together, we have to subtract the intersection, the outcomes in common. Okay? So to find the probability of non-mutually exclusive events, we're going to add the probability of each event occurring, and then we're going to subtract the joint probability, the probability that the probability of any event that occurs for both A and B, that intersection. That part gets subtracted off. Because if we don't, we're going to count some things twice. And then when you get a probability of more than one, that's not possible, right? Because that's because you counted somebody twice. So I think we've got the problem with the 2 and the even numbers. So this one you can just put down what I write down underneath that Venn diagram with the even and prime numbers, because that shows the information. You don't have to write what's up here. Just write what I write down. All right, so we want there are 3 ways to roll an even number. So the probability of even would be, there are 3 of them, would be 3, 6, or 1/2. There are 3 ways to roll a prime number. The 2, the 3, the 5. And you have that in your notes. You can see that from the Venn diagram. So the probability of a prime number is also 3, 6. So if we want the probability of even or prime, which is the same as saying the probability of even and or would be that union, prime. Right, we're going to take the probability of even plus the probability of prime, and then we're going to subtract the probability of even and prime, the intersection. Right, so what the numbers that are both even and prime get subtracted off. So probability of even, I'm going to leave it as 3, 6. The probability of prime is 3, 6. The probability of even and prime, there was one number here, the 2, in the intersection. So the probability of getting a 2 is 1, 6. Because there's one of them on the dice, and there's 6 outcomes altogether. So our probability is going to be 3, 6 plus 3, 6, which will give us 6, 6. But it's not certain that we would get a prime number, an even number, because we have to subtract off the intersection. So it's actually going to be 5, 6. So the outcome 2 is counted twice when the outcomes are added, right, because it was counted for the prime and it was counted for the even. The actual number of ways to roll an even number or a prime number is 5. Because there is one outcome that's not listed. What's the one outcome that's neither even nor prime? 1, yeah. 1 doesn't fit either one of those. The concept of subtracting the outcomes that are counted twice gives us our probability formula. So we're going to subtract anything in the intersection. Any questions on this so far? All right, so we're going to continue on for a little bit. We get out at 49, so we'll stop at like 44 or so. The probability on a number cube of rolling a 4 or an even number. All right, so let's figure out, we have to figure out the probability of each of our events and the probability of the intersection, because these are not mutually exclusive. So this is not mutually exclusive. This might be on the back page. Is it on the... Oh, it's at the very bottom of the page. All right, so probability of even or 4 or even. All right, so this is not mutually exclusive. So if we were looking at, we'll look at a little bit, I'll make a little Venn diagram just to help illustrate that. Whoop. Whoa, thank you. All right, so rolling a 4. So this is the group A. Rolling a 4. And then we have group B, which is the even. And they are not mutually exclusive. Right? And then the whole set would be all of the outcomes together. We'll look at Venn diagrams in more detail a little later on this lesson. All right, so the rolling of 4 has only one event, right? Or one favorable event, right? Outcome, right? Just the 4. That's the only favorable outcome. The rolling an even number has 2, 4, and 6, right? And then 4 is the overlap. And then not in either one of those groups is the 1, the 3, and the 5. That's outside those two groups. So the probability of rolling a 4 is going to be the or even is going to be the probability of rolling a 4, right? Which would be 1, 6. There's one outcome. Plus the probability of rolling an even, and there are 3 of those, 2, 4, and 6. And then we have to subtract the probability of the intersection, which is the 4 minus the 1, 6. So our probability of rolling a 4 or even is going to be 3, 6. which is, what would that reduce to? 1/2. So that's the last word at the bottom of the page there. So Venn diagrams are very useful at keeping track of things. And they're easy to draw. We want to find the probability on a number cube. This is at the top of the 4th page. Rolling an odd number or rolling a number less than 2. All right, so rolling odd. I'll do a little dead Venn diagram over here. I have a little space. So we have one circle, oops, that's odd. And one circle that's number greater than 2. All right, and then we'll decide where everybody goes. All right, does it go in, so this will be group A, this will be group B, because we have the intersection, and then we have the outside. So let's go through the numbers. Where would 1 go? Is that in A, B, the intersection, or the outside? It's odd, right, but it's not greater than 2. So it would go right here. How about 2? Does it go in A, B, the intersection, or outside? The number 2. What's that? Outside. Outside, yep. It's not odd. It's not greater than 2. It's on the outside. How about 3? Intersection. It's odd and greater than 2. How about 4? Greater than 2. How about 5? How about 6? Right, so now we can see all of our probabilities. All right, so let's do probability of odd. What's the probability of odd going to be? Yes, there is purple 3. What's the probability of odd?
1.
No, got to include everybody in odd. 3, yeah, 3 out of 6. So we're going to take, oops, I have it over here already. So probability of odd is going to be 3, 6. How about the probability of greater than 2? Green 3. So how many were greater than 2?
4.
Yep, 4, 6. And then we got to subtract the intersection, the odd and greater than 2. So yellow 4, what would we, no, yellow 4. Yellow 5, what would we subtract?
For the green quotient?
Yep.
2, 6.
Yep. So that means we have 7, 6 minus 2, 6. So our probability is 5, 6. Right? So we're gonna add them all together, and then we're gonna subtract the intersection. And these Venn diagrams are really useful for keeping track of information, and they're so easy to make. So we'll make lots of Venn diagrams. So put this in your notes, including the little Venn diagram. And we'll skip over to the closing now. So tomorrow's going to be, I'm going to stop recording. Bye, people.